Juliana. Let me. Again. No. So down arrow goes to the next slide, the up arrow goes to the previous slide. Okay.
This is Diana Ramirez, and my topic was what earthquakes of similar magnitudes in different regions of the Earth cause approximately the same levels of damage necessarily. In your explanation, consider both geologic and human use. So first is characteristics of earthquakes. So the magnitude of an earthquake, or how much energy an earthquake releases, impacts how much damage can be done. However, since there are many characteristics to earthquakes can have similar magnitude and still be different in other characteristics. Many characteristics for earthquakes are the magnitude of it, the depth, the distance from the epicenter, the duration, and the fault type. So first is the geological factors. The first one is duration. So the amount of destruction depends on many other factors besides magnitude. For example, the duration of earthquakes also makes a difference in how much damage will be done. There can be earthquakes with similar magnitudes. The one with the longer duration will cause more damage because the environment will be more exposed to vibrations for a long time. The next one is depth. The depth of the earthquake is the distance from the earthquake or from the Earth's surface to the focus or point of origin of the earthquake. Shallow earthquakes occur between 0 to 70 kilometers deep and are more destructive because they are closer to the surface, meaning that they are able to release more energy onto the surface, causing more destruction. There are also intermediate earthquakes that are between 70 kilometers to 300 kilometers. And then there are also deep earthquakes, which are 300 to 700 kilometers. They are farther from the surface. Their energy typically doesn't always reach the surface or reaches the surface with weaker energy, causing these earthquakes to cause less amount of damage. And then human-induced factors. Countries or regions that have buildings with built-in earthquake-resistant techniques are more likely to have less damage because they are specifically for the safety of people and buildings. Countries or regions that have no plan for an earthquake or any architecture and techniques for preventing damage from these earthquakes would be more damaged. There are strong materials, for example, reinforced concrete, which has concrete poured around bars of steel. This creates a stronger support and are used in areas where earthquakes are more occur. Whereas buildings in other regions that have adobe or concrete buildings, usually found in areas of poverty, are less likely to have strong support for extreme weather conditions, such as an earthquake, causing more damage even if there are earthquakes of similar magnitude. And then the conclusion is that earthquakes of similar magnitudes in different regions of the Earth would not cause the same levels of damage. The magnitude alone of an earthquake cannot predict the damage that will be left. There are many factors to consider, like the duration of the earthquake, the depth, and the locations of these earthquakes. It is possible for earthquakes of similar magnitudes to have drastic amounts of damage at different places. And that's it.
Thank you. Lana is not here. So next is Matthew Brown. Yeah, okay. You just check this board. So here we go. Down arrow goes next slide, up arrow previous.
Oh, it's weird, but okay.
Right.
Well, hello everybody. My name is Matthew Adam Brown. And today I will be showing you guys my physical science presentation. And when it comes to the thing I chose to present on, I chose to do it on Pangea. Yay. Well, I chose Pangea because I thought it was very interesting. The ideas of all seven of the continents coming together to form one massive supercontinent, I thought it was a very interesting topic. And the main question I posed with this was how did all seven of them eventually go apart into what we know as today? Well, we could start with the basic info on Pangea. Pangea was a supercontinent that existed 335 million to 770 ish million years ago. The timing of it is not exact because it's in the millions, so it's kind of hard. And as I said earlier, it is the formation of all of the continents around the world going into one. And then for the formation, and getting more specifically, as I said, 335 millimeters ago it started, all the combination of all of it. And it's surrounded by a massive body of ocean, or what was called at the time, or what scientists have called the Panthelos or Anthalassa. It's a lot of A's and S's, so I get confused there. And when it all came together, as you can see from that picture, it roughly made the shape of the letter C. And it also notably had both the South Pole and the North Pole coming together. And then the main things of formation for Pangea was Euramerica and Gondwana. Sorry, Pangea is a combination of that. Then Euramerica before Pangea was created 460 to 300 million years ago. And it is the combination of two of the continents of Laurenita, which is what we would call North America today, and Baltica, which would be the modern equivalent of Northern Europe. And the same goes for Gondwana, which is made up with multiple other continents in the same way. It's not made two. And those helped to create it. But now we gotta talk about the breakup of Pangea. It's so sad. They were so well together. The breakup of Pangea happened around 170 million years ago, which is what the end of it would be. This was due to the Earth's tectonic plates being affected by the convection currents in the ground, and specific breaks happened at weak points throughout the Earth's crust, which helped it break up. And it was also helped that volcanic activity helped rift apart the land from the already weak points around the Earth, which helped over time form the continents that we know today. And now we didn't just start off knowing all this, so we go back to 1970 or 1915. I was just saying, Pangea was discovered, where Pangea was discovered by geologist Alfred Wegener in Germany. He discovered through the years of the theory that he called continental drift theory, which is just the theory that they all drifted apart. And he used evidence of the continents fitting together like jigsaw pieces as a point. And he also brought up how on one faraway continent there would be fossils from another faraway continent that just couldn't exist if they weren't already together at some point, which at first many just scientists in general of different sorts doubted this until over the years it was course corrected, and it was now seen as the main inspiration to finding out about Pangea. So yeah, it ends off there. And thank you guys for listening.
Okay. Please. Going over to his left. Yana. Not here. Neither is Nancy or Guadalupe. And then Ishmael recorded his in advance, so I guess I could play that since none of the people who are supposed to be going are here.
I'm going to talk about the life cycle of a star. So, what is a star? Stars are giant balls of gas.
Yes.
I'm going to talk about the life cycle of a star. So, what is a star? Stars are giant balls of gas, mostly hydrogen, with some helium and small amounts of other elements. The birth of a star. Stars form in a large clouds of gas and dust called molecular clouds. Molecular clouds are cold, which causes gas to clump, creating high-density pockets. Eventually, gravity causes some of these clumps to collapse. The main sequence, the star's longest life stage. A star's energy comes from nuclear fission. Hydrogen fuses into helium. Fusion releases energy that keeps the star from collapsing. This is the longest stage of a star's life. A star's mass controls how long it lives. Small stars born slowly live longer. Massive stars born fast die young. Our sun is a main sequence star, red giant or supergiant. When hydrogen runs out, the core shrinks and outer layers expand. The star becomes a red giant, small medium star, or supergiant in massive stars. The star cools and turns reddish. The death of a star. Low mass stars. When hydrogen runs out, the core collapses and the star expands. Low mass stars like our sun become red giants, then from outer layers form a planetary nebula, and the leftover core becomes a white dwarf. Height mass stars keep fusing heavier elements until iron forms. Core collapses, massive supernova explosions, and leaves behind a neutron star or black hole. The element relays create new stars and planets.
Okay. So there's Ishmael. So we're Deanna and Nancy are not here right now. That's who's left. Um. That's all who's left. Let's see. I'll wait a little while. If they don't show up, I'll let you guys go. Um. Happy to answer any questions you have about anything. But have a nice holiday. Yeah. Yeah. My grades are due on Wednesday next week. So before then. But, how much before then depends on how fast grading goes. But they'll definitely be done by then. Probably done before then. I'll keep accepting late work through. But I will wait until after the weekend. I'll keep accepting late work through the weekend. For any of you who have late work to turn. So. And. You can always look at Brightspace to see where things are at. Yeah, the grades are due for all, probably for all regular length classes on Wednesday. So we'll definitely be done on Wednesday. Probably done before.
Today's the last day.
What?
Today's the last day.
Today is definitely the last day. I am not coming back. Well, until next semester, but. Yeah, last day I will be here, but you can still submit stuff on Brightspace. If you have something you have to turn in. Okay, they haven't shown up. I'm not gonna force you guys to wait around.